Hello everyone, this is Dynamics Inside Microwave brought to you by Simon and Eddie. So, what are we doing with Dynamics in Microwave? Let's get started. So, here's our objectives. What is the angular velocity and acceleration of the turntable? And what is the max weight that we can put in the microwave that it can still spin? And also, what impact does the weight of food have on the angular velocity and acceleration of the turntable? So let's look at a motor before we head into calculations and dynamics. So here's the motor that we have in our microwave in PCB. So we can see its speed and power and a bunch of other properties like voltage and frequency on there. So here we really just need speed and power. And then we can calculate the torque of the microwave by this formula, which is 9.5488 times power over speed. And we calculated that the torque of the motor is 4.77 Newton meters. And then we will measure a couple of things. The mass of the turntable, after we measure, is 1.158 kilograms. And then um, the plate that we put on the turntable, as we measure, is 0.354 kilograms. So the mass of the plate is just something that we are using here. But really, it will be the mass of food if we are calculating. And then we also look at the radius of the turntable and radius of the plate. And we could uh, measure them with a ruler, and we can see that radius of the turntable is 0.155 meters and radius of the plate is 0.0975 meters. So here, as usual, we draw our FBD and our MADs, and with the X and Y axis, and label all the forces. So on the turntable and the plate together, we'll have normal force, and then we'll have both of their mg's going down, and yeah. So yeah. And then on the MAD, we will have this moment which equals to I bar alpha. So here, what we are going to do is we are going to apply m equals I bar times alpha, and then we can calculate that with no plate. Um, we know m, and then we can calculate I with radius and mass, and then we can know that A naught equals 342.91 radians per second square. And then after we put a plate on it, we plug in the new moment of inertia, and we can calculate that the new alpha equals to 306.2 radians per second square, which makes sense because the microwave almost accelerates to its constant angular velocity instantly. And as we can see, it only takes 0.002 seconds for it to reach a constant angular velocity. And that's why what it seems like to us is that it always rotates in constant velocity. And after that, we can generate, we use Excel to generate relationship of alpha and I. And we get our relationship here as y equals negative 8,969.4x plus 431.38. So we got that equation. Then we can, and then here the x value is mass moment of inertia of things that we have inside, and then the y is the alpha, which is angular velocity in radians per second squared. So here's our equation again. We just replace x and y with alpha and I, which is what we have. And then assuming the food had geometry of a plate, then what happens is that we plug in alpha equals to 0, and we can find I. After I, we have I. We can find that the mass of things that we put on there equals to 7.4 kilograms. So our conclusion is that 7.4 kilograms is the max load for the turntable to rotate. If you put food more than 7.4 kilograms in a microwave, the turntable is not going to rotate. So how much is 7.4 kilograms? Well, to visualize this, 7.4 kilograms is 16 pieces of steak, assuming each pieces of steak weighs a pound. Or It's 241 pancakes. So, yeah, after all, our conclusion is that it's pretty much impossible for anyone to break their microwave as long as they, which, since putting 16 pounds of food in your microwave is extremely hard. But if you do, then your microwave might break. And also, all our calculation is assuming that the food has geometry of a plate, and then we always put food at the center of the rotation, which is probably what you should be doing. And if you don't, it will create a much larger moment of inertia, and the maximum low of zero angular acceleration will be smaller. So yeah, your microwave will be less likely to work, or more likely to be broken. And that concludes our presentation. Thank you.